The last thing we're going to do in chapter 4 is titled Quadratic Systems. So what we're going to do is we're going to look at a system of two equations and we're going to find the solution to the system. One of the equations, or both, will be quadratic. So if we have a system of one quadratic equation and one linear equation, you can possibly have one solution. Look in the middle. If the line intersects the parabola at one point, there will be one solution. Or look at the left, there could be two solutions. If the line intersects the parabola at two different points, there will be two solutions. Or lastly, if the line does not intersect the parabola at all, then there will be no solution to the system. So we remember that the solution to a system is the point where the two graphs intersect. So that's what we're looking for. So the first couple of examples that we're going to do is we're going to look at a system where there is one quadratic equation and one linear equation. So we're going to do a couple of those first. So let's look at the first example. And we're going to do substitution here. Substitution is the method we're going to have to use because we can't do elimination because we're not going to have like terms with the x's. So there's no way we can do elimination here. So we have to do substitution. We're going to do algebra. So it's either going to be substitution or it's going to be elimination. But in this case, it's going to be substitution. So the first equation tells me what y is equal to. The second equation also tells me what y is equal to. So I'm going to say that negative x squared minus x plus 6 is equal to x plus 3. I did my substitution. I took what y is equal to and I put it into the second equation. Okay, so now I have a quadratic equation to solve. So I'm going to set it equal to 0 and solve the equation. So I'm going to move everything to one side. So I get negative x squared minus 2x plus 3 is equal to 0. And I don't like that negative x squared. So I'm going to change all the signs. I'm going to multiply everything by negative 1. So I'm going to say x squared plus 2x minus 3 is equal to 0. And naturally, I'm going to try and factor. And if it doesn't factor, remember, if a quadratic equation does not factor, then we need the quadratic formula. So I think this one does factor. X plus 3 times x minus 1, that's going to work. So I set each factor equal to 0 and get two solutions for x. So since I got two solutions for x, negative 3 and 1, that leads me to believe that there will be 2 points of intersection. So I'm going to plug it back in, plug the x value back into one of the equations. Y is equal to x plus 3 is obviously the easier one to plug it back into. So we're going to plug it back in there. Y is equal to negative 3 plus 3, which is 0. So my first ordered pair would be negative 3, comma 0. And y is equal to 1 plus 3, which is 4. So my second ordered pair would be 1, comma 4. Okay, so that's not too bad. And it wasn't too bad because my quadratic equation factored, so we got some nice pretty answers there, didn't we? Let's go to the next one. So it's exactly the same, so I'm going to do the same kind of substitution. So I'm going to say x plus 5 is equal to negative x squared minus 3x plus 10, and I'm going to solve this quadratic equation. So I'm going to subtract x from both sides, and I'm going to subtract 5 from both sides. So I get negative x squared minus 4x plus 5. And once again, my x squared is negative, so I'm going to just multiply everything by negative 1, change all the signs, and then I'm going to try and factor. Let's see, x plus 5 times x minus 1. I think that's going to work. Let's check our work here. So we've got x plus 5. I'm checking all my work. Subtracting x minus 4x, subtracting 5. Okay, so we get x equals negative 5 and x equals 1. So once again, that leads me to believe that we have two solutions. So y is equal to x plus 5. So negative 5 plus 5 is 0. So my first ordered pair is negative 5, comma 0. And y is equal to x plus 5. So 1 plus 5 is 6. So my second ordered pair is 1, comma 6. Okay, so that's not too bad. And like I said, it wasn't too bad because the algebra was easier when we can factor and we get nice, prettier answers. Let's go to the next one. All right, we've got a little typo here. This little thing is not supposed to be there. That first y equals part is not supposed to be there. So we have this system, notice. We've got two quadratic equations, and they're both equal to y. So if I take what y is equal to here and I plug it back into the other equation, I'm doing some substitution. So negative x squared minus x plus 12, they're both equal to y. Both of the equations are equal to y, then they both have to be equal, don't they? So I'm going to make them equal. And I get a quadratic equation that I'm going to solve. So I know I have to set it equal to 0. So I'm going to move all the terms over to the other side. So add x squared to both sides, so I get 2x squared. I'm going to add x to both sides, so I get plus 8x. And I'm going to subtract 12 from both sides, so I get 0 there. All right, so then I'm going to try and solve this quadratic equation. Remember, the best way to solve a quadratic equation is to factor. And then your last option would be to use the quadratic formula if you need to. And so I think this one does factor because I think we have a greatest common factor. The greatest common factor, we always want to look for that, remember, first. The greatest common factor is 2x. So I'm going to factor out of 2x. If I factor out of 2x, I have x plus 4 left. So if I set 2x equal to 0, set x plus 4 is equal to 0. So I get 0 or negative 4. One more time, two pretty answers. That's nice. But now I'm not finished because I need the other part of the ordered pair. So I'm going to plug 0 in for x into one of the equations. I'm going to use the second one. Y is equal to 0 squared plus 7 times 0 plus 12. So that means y equals 12. So my first ordered pair is 0, 12. Then I'm going to plug negative 4 into the same equation. So negative 4 squared plus 7 times negative 4 plus 12. So that's 16 minus 28 plus 12. 16 minus 28 is negative 12. And negative 12 plus 12 is 0. So we get negative 4, 0. Perfect. Nice. So we always like it when we don't have to use the quadratic formula. Okay, so we did the same exact thing. Notice we did our substitution the same, and then our factoring. Our factoring was a little different, and we got two solutions. So notice two parabolas could intersect twice, obviously. One opens up, one opens down. Now let's go to the next one. So the next one is kind of the same, so we're going to do it again. We're going to do our substitution, x squared plus 5 equals x squared minus 4x plus 5. Once again, we have a quadratic, so we need to set it equal to 0. So I'm going to add x squared to both sides to get 2x squared. And I keep the minus 4x, and I need to subtract 5 from both sides. When I do that, I get 0, don't I? So once again, I get a quadratic equation. So I look to see if I can factor it. And I always want to look for a greatest common factor first, which is what I see. I see a greatest common factor. And the greatest common factor is 2x again. And so I set each factor equal to 0. So I get x equals 0 and x equals 2. So once again, I have to plug each one of these x values back into one of the original equations to see what I get for y. So I'm going to use y equals negative x squared plus 5. So y equals negative 0 squared plus 5, which is 5. So my first ordered pair is 0, 5. And then I'm going to plug in 2. So I get y equals negative 2 squared plus 5. So that would be negative 4 plus 5, which is 1. So my second ordered pair is 2, 1. One more time, notice we have a parabola that opens up, parabola that opens down, and they intersect twice. So it's going to look something like this. Okay, so it seems like we've done the same thing, but we just have two quadratics instead of a linear and a quadratic. Let's go to the next one. Okay, these are a little bit tricky. Let's see what we have here. We have a quadratic and we have a linear. So I think I'm going to do substitution. I see in the first equation it says x equals. So I'm going to change this second equation to be an x equals also. X equals y plus 4. So if x equals y plus 4 and x equals y squared plus 2y plus 1, then these two equations have to be equal. So I'm going to do my substitution. There it is. And once again, I end up with a quadratic equation. And so I can make it equal to 0, look at it, see if I can factor it. And if I can't factor it, remember, quadratic formula is the way to go. So I'm going to subtract y from both sides, and I'm going to subtract 4 from both sides. So I get y squared plus y minus 3 is equal to 0. And then I try to factor. And I'm thinking of the factors of 3, negative 3. So that would be 3 or negative 1, and negative 3 and 1. And I know that neither one of those add up to 1. So I know I need my quadratic formula here. So I'm going to say y equals negative b plus or minus the square root of b squared minus 4ac. Never forget our quadratic formula, all over 2a. Negative b plus or minus the square root of, let's see, that's going to be 1 plus 12. So that's going to be 13 all over 2. So I get 2 solutions, 2 again, but they're irrational. That's okay. So I know that x is equal to y plus 4. So x is equal to negative 1 plus or minus the square root of 13 all over 2 plus 4. So in order to add these two fractions, I think I need a common denominator. So instead of writing a 4, I'm going to write 8 over 2 because I know that 4 is the same thing as 8 over 2. And then I can add my numerators. So I get negative 1 plus or minus, nope, not. Negative 1 plus 8 is 7 plus or minus the square root of 13 all over 2. So I'm going to write my two ordered pairs now. So I get 7 plus the square root of 13 over 2, comma negative 1 plus the square root of 13 over 2. There's my first ordered pair. So notice I got the x value, the first x value, the plus. The second one's going to be the minus. Same thing for the y value. So 7 minus the square root of 13 over 2, comma negative 1 minus the square root of 13 all over 2. There's my two ordered pairs. It's kind of ugly, but there they are. So I just added 4, so I added 8 over 2. So I added 8 plus negative 1, and I got 7. And the plus with the y value went with the plus and the x value, and the minus went with the minus. Okay, we're going to do that one more time. That was kind of ugly, but we're going to do it one more time, just to make sure everybody's sure. So in this first equation, I think I need to subtract y from both sides to get y all by itself. 2y minus y is equal to y. So y is equal to negative x squared plus 1, and y is equal to x squared minus 5x minus 2. So if both of the equations are equal to y, then they have to be equal to one another. So we're going to do our substitution and set the two equations equal to one another, just like that. And one more time, we end up with a quadratic, so we're going to set it equal to 0. So I'm going to add x squared to both sides, and I'm going to subtract 1. So I get 2x squared minus 5x minus 3. And one more time, I'm going to try and factor this. Always a good idea to spend a little bit of time, just a second or so, trying to factor, because if it ends up factoring, your life will be a little bit easier. So let's see, if I put a minus 3 here and a plus 1 there, I get negative 6 plus 1. Negative 6 plus 1 does give me negative 5x, so it does factor, hallelujah. So I'm going to set each factor equal to 0. So I get negative 1/2, and I also get 3. So I've got half of my ordered pairs. Now I have to go get the other half. So if y is equal to negative x squared plus 1. So I'm going to plug in negative 1/2 for x. So negative 1/2 squared is positive 1/4. So it's going to be negative 1/4 plus 1, which is 3/4. So my ordered pair is 1/2, comma 3/4. So I factored, I got my two x values. I plugged the first x value into the equation y is equal to negative x squared plus 1 to get my y value. Now I'm going to do the same thing for 3. So y is equal to negative x squared plus 1. So do you see how I plugged in the x? In 3 for x. So So I get negative 9 plus 1, which is negative 8. So my second ordered pair is 3 comma negative 8. So that's it. So don't forget to, once you get your x value or your y value, once you solve your quadratic, you got to go back and plug it in to get your other half of your ordered pair. So notice we had two parabolas again. One opened up, one opened down. So they ended up intersecting twice.